Drones are unmanned vehicles, such as aircraft or rovers that can navigate their environment autonomously without need for human intervention. They have become an indispensable tool across many industries for their capabilities in mapping, image recognition, and targeting. Raytheon Technologies is a defense and aerospace company that annually hosts the Unmanned Aircraft Systems University Innovation Showcase in order to encourage innovation among engineering undergraduates in this rapidly expanding field. Multiple teams representing their university will compete to develop and implement the best unmanned vehicle system to complete a series of tasks. UTA's team is composed of 3 smaller teams from the electrical, mechanical, and computer engineering departments to provide students an interdisciplinary experience where specialized groups work together to create a product greater than the teams could achieve individually. The unmanned vehicle system consists of an unmanned aerial vehicle and an unmanned ground vehicle with their own respective communications networks. In a mock battle scenario, the UAV must be able to detect the UGVs on the field by recognizing their mounted Mella-Rijo marker, wherein they will fire upon enemy drones, that being our competitors, and recognizing our own as a friendly and ignoring it. The UGVs will undertake a series of paths within a 50 by 50 yard section of our venue, the Maverick Stadium, during which the UAV must still be able to detect and hit as many UGVs as possible. For the first task, the UGVs will be still on the field. For the second, they will be moving in a straight line at a speed of 0.17 miles per hour. If the teams are tied in scoring, tiebreakers may be had where drones will begin taking turns in the middle of their path at various speeds. All the while, UAVs and UGVs must fulfill the rules set forth by Raytheon. The UAV must follow all regulations of the Federal Code of Regulations Title 14, Part 107, which governs the operation of small unmanned aircraft systems. It must be registered with the Federal Aviation Administration, and we must have at least 1 certified pilot. Both drones must operate completely autonomously. The UAV is required to have GPS with real-time kinematics or end-trip error correction as its navigation system. The UGV can opt not to have this, however. They also must not be allowed to exceed the bounds of the competition, that being the 50 by 50 yard field. The only way the UAV is allowed to detect the presence of UGVs is through the Mella-Rijo marker. No other beacons may be present on the UGV. All teams are required to use the ACE combat system designed by Video Aerial Systems, which is an IR-based miniature aircraft laser tag system which drones will use for its guns, receivers, and peripherals. When the UAV fires its gun, or when the UGV is hit, they must publish the message to an internet relay chat channel in the specified format. They must also sound the buzzer and light up LEDs while performing these actions. Our drones are controlled by autopilot modules. For the UGV, it is the Pixhawk 2.4.8, and for the UAV, it is the CubePilot Cube Orange. The autopilots allow us to make use of the firmware ArduCopter and ArduRover, robust systems that allow us to connect with a ground control software, Mission Planner, that can map missions, set and tune parameters, see and interact with telemetry from the drones, and allow us to use the auxiliary functions necessary to complete the rest of the task. The modules have internal accelerometers, gyroscopes, and magnetometers, while also directly interfacing with a variety of sensors, including GPS, cameras, telemetry radios, and all its actuators. Data from these devices feeds into an algorithm known as the extended Kalman filter to estimate the relative states of parameters like position and velocity. Great care is taken to minimize interference between the sensors themselves and other sources of interference in the environment and present on the drones, like for example, the power lines. This is all part of a complex network of communications. The drones take GPS data from satellite systems and error correction through Mission Planner's RTK injection, using the RTK station on the roof of UTA's Netterman Hall as a source. We also have a telemetry radio that allows us to directly monitor and communicate with the drones from the ground control station. For safety, both drones have a kill switch implemented, where we use an RC transmitter or joystick to end missions prematurely and safely. For functions that the autopilots can't perform, such as our IRC script connection, there is a companion computer, the Raspberry Pi 4B, which runs the Python scripts that create bots that handle the publishing of the necessary messages. The Pi is connected to the autopilot through a serial connection, and the ACE Combat is connected through its GPIO ports, where it takes the respective necessary data to trigger our script's publishing mechanism where necessary. The drones were built iteratively over the course of 2 semesters. Each time we optimized the design for modularity, minimal interference, and structural integrity. Raytheon afforded each university $5,000 to develop their UVS. We used these funds, the available resources and experiences of last year's team, and UTA resources and mentorship to create a complete, robust unmanned vehicle system that is sure to excel at the task laid out for it in the competition.